So I think we can get started now. Then people will join afterwards. So hello and good evening, everyone. Welcome to today's session on AI system, building responsible ML system with AWS. And today we have an exceptional guest joining with us today, which is Mobasshir Bhuiya, who is a lead data and machine learning engineer at Graaho Technologies. Graaho Technologies is actually a partner with AWS, and we are really delighted to have Mobasshir Bhuiya, who actually brings an exceptional experience to this tonight's discussion. So, without further ado, let's get the Mubashir Bhuiya the floor. The floor is yours, Mubashir Bhuiya.
Thank you so much, Bear. Hello everyone. I'm Mobasshir. I'm the staff machine learning engineer at Graaho. Besides, I work as a alliance lead in Amazon Partner Network on behalf of Graaho. So, uh, Thank you again for joining today. Hopefully, we will get some gist for responsible AI. Uh, are we going to start?
Yes, sure, you can get started.
Okay, sure. Uh, for some reasons, my background is not working at this moment, so that's why I would like to uh, close my video. Is this a problem?
Yes, sure, no worries, Bhuiya. You can take your time.
Okay, sure. Thank you.
Yes, sure.
Let me share my screen. Okay. I don't hear you actually. Zainal bhai, I don't hear you. You're mute. Zainal bhai, you are on mute.
Yeah, Bhaiya, you can share your screen.
Okay, sure. Thank you.
Also, if you have any question, all of you can write the question in your chat. We will also have a question answer segment. So you can also ask question, unmute yourself and ask question that time. So that's it from my part. And Mubashir Bhai, you can continue.
Sure. Definitely. Just let me do something. Can you see my slides?
Yeah,
Yes,
we
yes.
can see your slides here.
Just let me give the URL to some people that I'm just getting back.
Yeah, sure. No worries.
I'm sorry, guys. So, can you see my screen right now?
Yeah, Bhaiya, we can see your screen.
Okay, thank you so much for that. So, today we are going to talk about the AI safety and bias detection in production. So, we want to basically build responsible ML systems with AWS. So, this is an This is an accessible introduction to build fair and responsible AI systems using AWS tools, as we are the partner of AWS, and at the same time we work extensively with AI. That's why we thought to present this webinar with AWS. So no advanced ML expertise required here, because we actually concerned about the beginner or intermediate level, as responsible AI is a very complex domain. That's why we won't go that much deep. We will definitely touch the surface of the beginner and intermediate level. So I would love to start with one of my experience. Uh, like when I deployed my first ML algorithm, uh, I almost I was up the whole night during that day. Basically, we launched a recommendation system that performed beautifully in our testing data set, which was actually curated from our own platform, which is named Kaggle. And we almost got 99% accuracy in the testing. But 2 weeks later, when we started getting the uh, customer tickets in the customer support, at that time we could understand that something is wrong. So the system was systematically ignoring the entire demographic segment. It was actually trained on a data set where most of the customer was almost male, and there was a very low percentage of female customer data. So this issue occurred not because we wanted it to, but because our training data had a blind spot we never caught. So at that day, we could understand that AI related safety isn't just a checkbox. It's a continuous process. Like we do the software security testing in the earliest time, and we do changes accordingly, and then we submit the project to the client. That's the same thing. So in this webinar, I tried my best to give some gist regarding the responsible ML and ML systems, and also the bias and about the fairness as well. So that's why we will start with a bias actually. So what bias actually looks like in production? So we this is a terminology that we hear almost all the time, but what is actually bias in the production? So bias isn't always obvious. It hides in our data pipeline. That's being said in our textbooks, or in slides and everywhere. So they can also be said that think of bias like rust on a bridge, but you don't see it until it forms some sort of physical structure. So that could be one thing. But there actually, in the real world, there are several types of bias. Uh, in most of the cases, we see three types of bias. One is selection bias, another is label bias, and the other is measurement bias. Uh, so for the selection bias, assume that you have a training data set, and that training data set belongs to weather prediction related data. And you just trained the model with that data only for us, only for a specific region, name it like Gulshan or something like that, Mirpur, that could be Mirpur as well. But when you are just giving the inference, in that case, you were just using that specific region training data to whole over the country. So in that case, you were just introducing the selection bias to our algorithm. If we talk about the labeling bias, the scenario could be like when you used someone as a human labeler, and they were just employed for daytime, and that in that case, they have only got the business hours data, right? But they miss some sort of night shift related data, or the data that can be generated in the night. So in that case, we are not actually getting the proper fairness or properly generated data. So that data is basically the labeling bias. And for the measurement bias, we could say that we have some sort of measuring like that could be the thermometer or something like that. So in that case, we are just measuring with a thermometer that only works with a temperature that could be between the 100 degree Fahrenheit or above. That doesn't measure less than 100 degree Fahrenheit. So in those cases, we introduce measurement bias. So in production data, you could see so many cases for this type of selection bias, this type of labeling bias, and this type of measurement bias. So these are the predominant bias types of bias in the production cases. So I can give one example that happened with me while we were working with one of the NLP projects in Rainforest, Australia. We actually discovered one of our sentiment analyzer rated a professional language like English as positive. Uh, uh, that professional language that is used in corporate cultures as positive, and casual language as negative. Not because that was being selected not because of actual sentiment, but because of our training corpus came from almost from business reviews or business culture, something like that. So that's why there some sort of measurement bias was introduced in action. So this is basically one part of one part what bias actually looks like in production. But another thing is what we do with what we can do with AWS. So the AWS safety stack we actually use. So in that case, AWS gives us some tools, but in most of the cases, um, we can't just use AWS services. In that case, we need to develop a system for ourselves. And for that, we work in AWS basically in a layered approach. That is almost 3 layers. In layer one, we do some pre-deployment detection. So in that cases, we use SageMaker Clarify. SageMaker Clarify is a very popular tool in the current date. You can just Google that anytime. And for that, like how we use SageMaker Clarify, the use cases could be like if before sending any models to live, we run SageMaker Clarify to get the post modeling bias detection. So we could say that it is some sort of bias model metal detector or something like that. And besides, we can also use that in the pre-deployment stages, like when you send data for the modeling. Before that, you can just check your data that is there any bias exist or not. So clarify helps in both cases. So it checks if your model fits different groups fairly by measuring prediction differences across demographics. That does mean that if you are actually checking your data on checking data biases for female and female both groups, are they giving you the true positive rate or false positive, whatever the result is for the same group equally. That's the checking point. So for a quick win, we almost all the time set up a bias matrix during training. It takes not more than 10 to 15 lines of code, but it saves us months of remediation in sometimes. So at the same time, using the SageMaker model monitoring, we can do some runtime monitoring. So this is basically some sort of early warning system once uh, we can get while we run our system. Um, Besides, we can have besides, we can have the human in the loop guardrails, which is Amazon Augmented AI, which is the third layer of our AWS use case. In some cases, some sensitive data that could be hospital data or some sort of loan data, we send those predictions to human review, and after getting those human review, we use that inference for the our users. So that's the AWS part of the thing, and there are some strategy that actually works in the detection, which is my core third core message. Is basically the proactive beats reactive every time. So we actually work with some sort of monitoring dashboard. Like in this dashboard, we work with 3 or 4 types of metrics, and in those metrics, some popular one are demographic parity difference, as you can understand from these. These are basically checking that different groups getting similar approval rates, or we can have equalized odds as well. Like when the model is right, is equally for right for everyone or not. This is some sort of thing. And also disparate impact ratio is another metric where you actually check that is any group getting decisions at less than 80% of the rate or not. So this is one of the important metric that we uh, use most of the time in our dashboards. Also, we can have a calibration curve as well. Like when the model says 70% confidence, is it actually correct 70% of the time for all groups or not? So these are the things that we do in the detection strategy. Besides, we have some automation pies as well. So there are some CloudWatch plus Lambda plus CloudWatch plus Lambda implementation as well, which we run recurringly almost every day. We check different metric shifts there, and based on that, we get some Slack alerts, and based on that, we take some measurements as well. So alerts, or this type of automation takes very less if you are using AWS. So we will talk um, um, comp- uh, briefly at this moment, but we will deep dive into that in the upcoming slides. So there are some hard truths about fairness. So perfect fairness is mathematically
Bhaiya,
impossible. Yeah.
I think you are on slide one. No?
Yes. I'm slide one. I'll be just moving.
Yeah, sure. Bhaiya, do you accept the new ones who are coming right now? Like many of
Uh,
people are
I
DMing me.
think this is done by Mimapu.
Watch.
Okay. So there are some hard truths about fairness. So perfect fairness is mathematically impossible. So you must choose trade-offs explicitly. We are going to talk about that. And there are some cultural shift as well. In the past, when I was working with uh, Rainforce, I had a doubt about my model, but the regulators or the management didn't accept that. So we will be moving in the next slide, and we will talk in a detail about that. Okay. So the cost of unchecked AI bias, that is our very first slide that we are going to talk in a detail. So before we talk about tools, let me tell you about a $240 million dollar mistake. Basically, Amazon built a resume scanning AI. Definitely, that was a brilliant engineering. But there is one problem. It systematically dowranked women. So why it happened? if you are asking me this question, so because the model learned from 10 years of historical hires, and mostly that time there was very less amount of computer professionals. So that model think like a good candidate looked like the past patterns. So, but there was some pattern changes, and that model actually was so much biased that it took the gender as a prime factor to for the prediction. So here we have some sort of punchline. By the time they caught it, the reputational damage cost more than the settlement. They did. So it was a something bigger scam at that time, maybe back in 2018. So we there isn't some uh, so today we are covering practical systems we use to prevent this. How to detect first, we are going to talk about how to detect bias before launch, not after lawsuits. You can see in the timeline. Then we are going to talk about techniques to actually fix it, not just document it. Third, we are going to talk about making models explainable so stakeholders trust them. And in the fourth, we are going to talk about governance frameworks that scale. And in fifth, we are going to talk about staying compliant with slowing down innovation. So by the end, you will have some intuition, not just theory. Definitely, we are going to talk about in details about everything. We actually treat fairness like we treat security as a non-functional requirement. So previously, it was being thought that if you are just working with the bias or fairness, something like that, which actually makes a responsible AI. In that case, you are going to wasting your time. So that's not being thought at this moment. We do bias and fairness check when we deliver model to the production. So uh, you can see in the you can see in the timeline visual, you can see the progression, the like bias introduced, model deployed, and lawsuit filed, brand damages, and customer trust eroded. So this is the timeline that often being shown when you are talking about responsible AI. So this is a very common timeline. So every step to the right gets exponentially more expensive to fix. We are staying on the left side of the timeline. So as fast as we can solve, as we can adapt these changes, we will have less expenses to fix those issues. So let's build the systems that don't end up on this timeline. We will learn more about this in the next slide. So what is the anatomy of bias from data to decision? So bias actually starts when you are just collecting your data, right? So the most uncomfortable truth, this is the most uncomfortable truth is, so everyone thinks like that bias happens in the algorithm level, but it actually comes from the upstream. So I have like we will when we debug different data sets, we can see that uh, there are so many different uh, bias introduced, like that could be gender, that could be age as well. So this is sort of like I have debugged dozens of bias models. 90% of the time, the model was just learning what data taught it. So I have to reframe again. That bias is a system problem, not a model problem. So we can see three types of biases. One is historical bias, which actually comes from our data. So our data actually has some sort of past. This is when our training data reflects real world inequality. So in one of our earlier works that we did in Caspera, we made a credit scoring model. We actually trained 5 years of loan approvals data. And in that case, in those 5 years of data, we could see some sort of redlining practices, and our model learned that it was actually based on USA data. So their zip code is very much popular, and their based on the zip code, the model actually learned that if you were in some sort of zip code, you were some posh people, so you can be given the loan. So this sort of bias was introduced by historical data. So in that case, we use Clarify, Amazon Clarify to figure out those biases and also yeah, remediate those biases. And we also talk about the measurement bias. Uh, Actually, this is being said that measurement bias, when we actually collect the data, uh, that data was skewed or something like that. In that case, the measurement bias happens. As already I have talked about that, given the analogy of the thermometer. We have also the evaluation bias. So you actually test your test set looks nothing like your actual users when you actually made the recommendation model or something like that. You have some sort of cold start problem. So in those cases, when you face new users, you face so many you can't actually recommend product or item to that users. Uh, so you do some sort of filtering, collaborative filtering, or something like that. In that case, you make some bad evaluation because you only know that some people or some group of people have bought that, but you don't have any other information about that. So you do some evaluation bias in that case as well. So uh, so we will walk through the cycle. So we can see that bias data trains the model, and models makes biased decisions, and those decisions generate new data, and which eventually reinforces the original bias. And it is often being said that a model can be statistically sound and is still ethically flawed. That's because of the bias. So you can read it again and again. We often use in our day-to-day life, or in our profession, or while we are in academia. In that case, we use some sort of metrics like ROC, AUC, precision recall. We get some good results out of those metrics. But at the end, we don't get the proper outputs that we desired while we building those models. That's basically because of one sort of outcome of bias. So how do we actually measure a model is fair or not? That's not dependent on the accuracy or F1 score, something like that. To measure those things, we need the fairness and the fairness metrics. And in the next slide, we will be talking about that. So measuring fairness beyond accuracy. So as I already mentioned, that you can get some good accuracy scores, but that doesn't imply into some fairness. For that, we can I can show you some models that gives you the 95% accuracy, but that could be catastrophically unfair. We have worked with some sort of fraud detection model, and in some cases we got 96% accuracy. But the problem was uh, for some demographic segment, it didn't give the expected output. Like we worked with Rainforce and we worked with HSBC Australia. In that case, it was just giving almost 4 times of transactions opportunity to some users because those users had some sort of demographic bias. So And that is a that is that shows how accuracy doesn't matter when you are actually working with the fairness. So in that case, we could say that this is a high accuracy doesn't tell you what who you are getting wrong or something like that. So fairness, see, we have four fairness metrics. One is demographic parity. That does mean that equal outcomes. The analogy could be, are different groups getting approved or flagged or recommended at similar rates, right? So if 30% of group A gets approved, roughly 30% of group B should get approved too. That should be the case, but it doesn't happen when we have the demographic parity. So then we use another metric, which is equalized odds, equal error rates. What it means is actually when your model is right, is it equally right for everyone? When it's wrong, is it equally wrong? So that does mean we need to understand two metrics. One is true positive rate and one is false positive rate. So this is basically two parts. So in true positive rate, we actually catch the real cases, and in the false positive rate, we actually get the false alarms. So in that case, if two true positive rate and false positive rates are giving the same output, in that case, we can say that we are getting the equalized odds. So fraud detection example or cases, this this metric is very much important because legitimate users shouldn't get falsely flagged more often just because of their demographic, right? So like you don't have a cancer, but for the equalized odds errors, you got that you have cancer positivity. That does mean that you got the FPR, and you are just getting a bad result. So that won't work. And then in the third, we use the individual fairness, treat similar people similarly. So when two applicants are nearly identical profiles, so they should get that identical outcome. So that's another fairness metric, which basically treats similar people similarly. And as the fourth metric, we have the intersectionality, which actually look overlapping identities that basically question some sort, make some sort of question like why or something like that. Like when there is a problem that just depend on unique features that actually makes different features. Like yeah, when you are just checking on the gender fairness on a data set, it also checks is there any intersectional attribute available that can be used for checking the fairness. Like it could check like is there any relation with income and gender, like man with lower income, is there any change on the prediction or not? Man with high income or women with lower income, is there any consequences in the prediction or not? So this sort of thing is being checked by the intersectionality. Um, um, Intersectionality. And the hard truth, basically, you cannot remove the fairness from your real world data set because that's not mathematically possible. So that's the most important point, because every fairness has a trade-off matrix. So accuracy versus fairness. So making you, if you want to, if you try to make a model more accurate, then definitely you will lose the fairness. And if you want to make the model more fair, in that case, you are going to lose the accuracy 1 to 3%. and besides you also lose the stability. So in that case, like overfitting to fairness matrix can make model brittle to data drift. So that's sort of a problem. And also different fairness definitions conflict. This is a great problem because demographic parity and equalized odds. Demographic parity depends on genders, like ages or something like that, and equalized odds could be like uh, both positive and both negative is getting the same result or something like that. So this cannot exist, coexist actually. So that's why you have to trade off with accuracy and all. So for fairness, we basically use the AWS Clarify. Um, 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 Using AWS Clarify, you define protected attributes like which attributes you are going to use, age, gender, geography, or whatever you seem relevant in your data. And then Clarify runs some post-training analysis, calculates these four metrics that I have already mentioned, and you get some sort of bias report on that. And there are some sort of dashboard in AWS Clarify that shows which groups are under or over predicted by and by how much. So that's how fairness um, is measured by AWS Clarify. And measuring fairness is basically a one step. And previously we have talked about bias. And in this stage, we are actually try to fix that. So we want to do the bias mitigation, where we will use AWS SageMaker explicitly. So previously, when we deployed models, when we saw the accuracy, we thought like, oh, this model is going to work for production very well. And after some time back in 2021 or 2022, we used to do some sort of A/B testing, which model is working fine, or some manual testing. But after that, AWS introduced AWS Clarify, which actually works with the AWS SageMaker. That actually made things easy. So I have experience working with Australian regulators, and they're so much serious about the regulatory compliance. And previously, we used to work as a team to manage this regulatory compliance. But now this can be done using the AWS SageMaker Clarify, which actually costs you around 47 to $50 if you run this whole month. So that is a very good thing. So it actually it actually runs and gives you the automated bias checks on your production models. And also you don't have to put manual effort. You will often get automated alerts, continuous monitoring also run. So this is a very low friction and high accountability tool. So I'm for that you have to run your model into SageMaker. So this is the very first step. You start with your model in SageMaker. You can work with the CSV data or whatever data format you want. You put your data into S3 and you point your clarify to that S3 bucket. And then you do the pre-processing, run the pre-processing. So some data prep you are already doing with pre-processing. This basically checks your data before the model ever sees it. It actually gives you the idea about class imbalance. That also gives you the idea about label distribution skew. You see skewness, which actually distorts your normal distribution. Also, is there any underrepresented groups or different fair different fairness matrix violation as well? So in most of the cases, we use data sets from different companies, and there are some sort of disparity we see, and the most one of the most disparity that we see when we work with um, um, different companies is gender disparity. In most of the corporate offices or somewhere, we can see that almost 80 to 85% are male, and 15 to 20 to 15% are female. So we can see this sort of using this sort of imbalanced data for gender, you cannot better train a model. So before training any model, we if we use this sort of uh, tool, in that case, we can be beneficial, because after training the model, if you try to eradicate this bias or this violations of fairness, in that case, that becomes much expensive. So after we do the pre-training bias, after we get the pre-training bias report, we often train model using the SageMaker training jobs. That could be your machine learning model, XGBoost or neural network, whatever algorithm you are using. So Clarify can be run on this data set alongside your model training. So that could be run in parallel as well, and that will definitely not affect your training. So that's a very positive side of Amazon SageMaker Clarify. And after the training, your model can introduce some sort of bias as well. In that case, your Clarify will automatically run again, and it will check on predictions for different demographic groups. Uh, it actually measures at that time the fairness matrix that I already mentioned, demographic parity, equalized odds, disparate impact. All these metrics are being covered earlier. It checks again. So I have seen models where pre-training bias was low, but post-training bias spiked, because we maybe that bias was introduced by some sort of hyperparameter or something like that. Um, these things are definitely cumbersome, but yeah, it will fascinate you while you were working. The so after we after we run the clarify SageMaker Clarify, after the post training, we get some sort of bias analysis, and we get some metrics, and report is also generated. At the same time, you will get a dashboard from Amazon SageMaker Clarify, which will tell you everything. So Clarify gives you a side-by-side data bias and also the model bias report. You can export that report in JSON, or you can see some sort of visual dashboard or PDF summary, whatever you want to pick up. So in this sort of report, we actually see the disparate impact ratio. I couldn't make this presentation by myself. So I that's why I can't let you see the actual dashboard, but definitely in some future presentations, I will practically do some sort of workshop where I will present this. I'm not prepared today, so I couldn't do that. So disparate impact ratio is one of the most important metrics that's being used uh, for determining the bias or fairness in any model. So if it goes below zero point 0.8 or 0.75 something, that would be it does mean that your model is not appropriate or ready to go for production. And also at the same time, you see some sort of feature attribution scores, which actually shows which features are driving the unfair predictions. uh, we will see some sort of tool or techniques in the upcoming slides, which are being used for uh, getting these reports or metrics. Then as you already get the metrics and reports, and you already compared those metrics, one thing you can do, you can put this Amazon SageMaker Clarify into your CI/CD pipeline, right? So your SageMaker Clarify has been run, and metrics report has been generated. Your Amazon CloudWatch has got this information through the Amazon Event Bridge, and after that, your CI/CD pipeline runs. So if your CI/CD pipelines see that it the disparate impact ratio is less than 0.75 or zero point 0.8, something like that, in that case, it won't push your model to the production. So if you want your model to be pushed to the production, in that case, this ratio should be more than zero point 0.8. So we have set up, like, we have SageMaker pipelines, we have EventBridge setup, we have Amazon CloudWatch setup. So every model that goes through the Amazon SageMaker Clarify, that actually being checked by some sort of Lambda function. And if this Lambda function actually works as our CI/CD pipeline part, so if the fairness matrix goes beyond our threshold, in that case, that's being pushed in the production, or in other cases, that's not being pushed in the production. So we how it is helping us, previously we were manually doing this, but after we started using the Amazon SageMaker Clarify, then we got almost three problematic retrains in 6 months before it was pushed to the production. You can visit one of our product, which is named that is named Algorithmic, maybe. Sorry, that is named Algorithmic, and that product is basically a full-fledged recommendation system SaaS platform, and you can just train your own model there. And while you go through that web application, you will get the idea how things are being done. So all these things that I have already talked about, you can see there by running your own data set in that platform. So there are in this Amazon SageMaker Clarify, we have some sort of uh, compliance benefit as well. While we run the Amazon SageMaker Clarify, every Clarify report actually auto saves it to the S3 with timestamps. So when your regulators or managers is that asking for the fairness or bias reports, you can just have that within minutes, and you guys or other stakeholders can make any decision there. So also there are some business impacts if we talk about this. Like before we started using Clarify, we used to do manual quarterly audits in our models that it usually took around 2 weeks to 3 weeks, and 2 to 3 engineers. But after using Clarify, it has been degraded to 6 hours or something like that. And it also a part of continuous monitoring that actually saves our resources and the money as well. So it becomes part of our daily data pipeline or ML pipeline. So here's the philosophy: make the right thing the easy thing. So if fairness testing requires manual effort, it won't happen consistently, as we already see. If it's automated and frictionless, it becomes non-negotiable. You don't have to do these things by yourself. Amazon will handle all the things, as Amazon handle the ML workloads with SageMaker. It handles bias, fairness, all these things using the Clarify. So in the next slide, we are going to talk about the strategies, that is the pre-processing, in-processing, and post-processing. Um, so if we um, if we talk about our past, in past we actually thought that we will develop some data pipeline in our academia or books. There was something like um, some sort of detection documentation, um, something like that. So that was much expensive documentation, but those documentation doesn't work in the real world. So in the real world, in the pre-processing step, we actually fix the data. So in pre-processing, we fix the data. It is being said that clean up bias before training even starts. So if you can clean your data before training starts, in that case, you are actually minimizing the expenses or costs for the longer run. But it's not fixed. Bias and fairness is not a thing that you can solve in a day. It should be continuously monitored. That's how it works. So in the pre-processing, we use some sort of technique. We give underrepresented groups more weight during training. That's one thing, like balancing high scale, add weight to the lighter side. So you want to balance a scale and you add weight to the lighter side. So that's one thing. So if I talk about, I already talked about this, that gender inequity is a common problem in pre-processing, because in most of the data set you'd see less amount of female data than the male data. So that's one case. And as the technique two, we do some sort of synthetic data generation. We basically use some sort of artificial examples for the underrepresented groups, and when we don't have enough data. Uh, and it is being said that you should not use more than 20% of artificial data in any data set for basically in the pre-processing pipeline, because that actually make your algorithm more feels like artificial prediction or something like that. And to generate the synthetic data, we use some algorithm that's named like SMOT, SMOTE, which is synthetic minority oversampling algorithm. It basically creates new samples by interpolating between existing minority examples. Also, we can use the AWS Data Wrangler, which is basically a wrangling tool, or you could say the studio, because you can find lots of transformations, lots of cleaning, lots of feature engineering functionalities in that studio. So you can use SageMaker Data Wrangler for this purpose as well, to augment your data set. And in the we have another stage which is in processing, which is actually the modeling stage, and it is being said that teach the model fairness. So if you could stop your fairness violation in the in processing stage, which is basically the data stage, then you need to focus on the model stage. If we see the fairness or issue, or the bias issue, in that case, we use some sort of techniques for minimizing these biases. One of the technique is adversarial debiasing. And in the machine learning terminology, you may know the term adversarial. That does mean you have to go the other way, because in the positive way that's not working. So you in this way, adversarial debiasing, we basically train two models at once. One tries to predict my outcome, and the other tries to guess the protected attributes that actually influenced that outcome. So this way we actually do the adversarial debiasing. Basically, we penalize the main model if the adversary can figure out protected attributes from its predictions or something like that. There can be an analogy like we train a spy who leaves no fingerprints or something like that. So yeah, for real setup in TensorFlow or related implementation, we add some sort of fairness loss term to the main loss function that's being called as a fairness penalty. And with that, we multiply some variable named lambda. Basically, lambda is our fairness knob, where high value is equal to prioritize fairness more. So if we are putting high value in the lambda, that does mean that we are prioritizing the fairness more in that penalty. So high stakes predictions where protected attributes shouldn't influence outcomes, like hiring, landing, and medical diagnosis. And we have another technique named fair representation learning. You already may know that what representation learning incur. So it actually data representation type of technique. So we actually create a transformed version of our data where the bias is mathematically removed from the features. We actually create some sort of latent space that you can think of as a compressed encoded version of our data. So we do calculation in our data representation level to actually remove the fairness. So autoencoders actually learns to represent data in such way and that actually preserves useful info, but it strips out demographic patterns. So this way, basically, the pair representation learning works. And in the layer three, we work with the post processing where we basically adjust the output. We have removed the bias from the data layer. We have removed the bias from the model layer. Then we go for the post processing layer. Here we actually use different techniques that depends on your organization, that depends on your model and real world use cases or new research. But most commons are threshold optimization. You put some sort of threshold, like instead of predicting yes for probability point, if probability is greater than 0.5 for everyone, you put if for group A, I'm putting the probability threshold for 0.30, and for group B, I'm keeping the probability as 0.5. So you are actually keeping or maintaining different threshold for different group. So that's how we use the threshold optimization. And there are other technique as well, like output calibration. So it actually make you make you think like your predicted probabilities are accurate across all groups. Uh, this is like you actually check with your manual validation that your model is getting the output that you expected. If you don't see that, in that case, you do some sort of post processing in your model inference, and then you present that to the world. So this is called the output calibration. So in the fraud detection mechanism that is being done regularly, also you have AWS option as well. So SageMaker has different post processing transformers that you can use for these purposes. Uh, so we do follow some sort of strategic principle. We do the pre-processing fast. This is as I have already mentioned, that this is the cheapest approach. And I would say this is the most effective approach if you remove the bias and fairness parity from this earlier level. Then you don't have to check on model or post-modeling stage. Um, because uh, it is the first stage, and if that's insufficient and in processing constraints. So you can put some constraint in the modeling level as well and to process your bias removal or fairness removal, disparity removal. And also the post processing is your last resort for your quick fixes. If you want some results that is not needed, but in processing you have checked that yeah, there is no bias or fairness disparity. So you can do the post processing step as well. So these approaches or strategies actually mitigates the model fixes, uh, but we actually need to understand when and where we need to when and where and what need to be done. And for that we will use some tools or metrics, something like that. So we are going to work talk about explainability. Basically, that we when I started working in back in 2018, in that time, we didn't have enough resources. We used to think that once one of my vice president asked me what is actually model weight, and I didn't know at that time, and I told him that this is just a binary file, but this was just a weight. So I started machine learning that time. So machine learning was black box for me, but when I'm working with this thing regularly now, these things are not black boxes. So next, we are going to talk about the explainability. We are talking about the SHAP values, line, feature importance, everything that actually makes your model explainable to the world. So in this slide, as you can see that this is explainable AI from black box to glass box. So as I already mentioned that I couldn't explain what is the model weight to my one of my CTO or vice president. So that day I realized that model were black boxes, but now it is sort of like understandable. It matters a lot in your day-to-day life. If you have the basics of understanding your model, whatever you have done that could not be the production ready, or that may be not servable or underserved for your outcome. But if you understand how the modeling is being done, or you can explain your prediction or result to the employer, in that case that's going to be pretty helpful. So, uh, why explainability matters? Explainability isn't academic, it's operational. If you want to keep your operation up and running, in that case, you must understand your model. There is no other way around. Here, if you are working with EU countries or US-based clients, in that case, they will have regulatory defenses for their data. That's one, you have to sign some sort of NDA or something like that. In that case, you have to make sure that how their data is being used. That's one reason. And another thing could be it will help you debug your modeling, like why your model is misbehaving, or why it's not giving you the appropriate result. Or if you don't understand how your model actually behaves or gives the outcome, in that case you won't have the trust on your model. And at the same time, if you don't have trust in your own model, in that case stakeholders won't actually deploy that to the production. So it's being said that explainability translates model intelligence into human understanding. So for explainable AI, we use some techniques. We use one of the most important technique that I have already mentioned, which is actually SHAP. SHAP is not something that related to SageMaker, but SageMaker has an integration for it. This is mostly used to explain any model in the production. So that's the thing. So what it does actually, it actually shows which features pushed production up or down or by how much. So it helps you with your qualitative understanding at the same time, with the quantitative understanding as well. So that's why SHAP is so much popular and so much valuable in explainability of AI models. So it basically gives you some sort of receipt where you can see uh, the item you bought, which one cost how much, something like that. So it works in two levels. It works in global explanations and also the local explanations. So for the global explanations, it actually says answers you the question like, across all your predictions, which features matter most overall. So you have so many predictions, and for all these predictions, which feature contributed most in the prediction or influenced most in the prediction? That's one thing. And it also helps you in the local explanation as well. Like, for this specific prediction, like or for this specific item choosing, why this prediction is uh, why this prediction was made, or for this specific user, something like that. You can item value or uh, um, okay, the personal example would be much better. Like, for this specific people, um, why this prediction is being done or given, something like that. So this can be done from the SHAP. So it has, as I already mentioned, that it has the AWS SageMaker integration as well. So SageMaker has built-in SHAP support via Clarify. So it can be run on post training with your CI/CD pipeline. That actually take one command, and your SHAP values will be generated. As I have already mentioned, that report is being generated. It can be exported as JSON files as well, and you could see some sort of interactive plots by Seaborn or something like that, or Plotly maybe. You can have your dashboard as well. So in most of the productions, we store SHAP values in some sort of NoSQL databases based on the partition ID. In our cases, we do something like that because SHAP values help us to understand why a particular model worked back in 2018 or something like that. So in those cases, this helps a lot. So uh, we have another technique which is line. Lines basically help us understand the complex data types. It creates simple interpretable model that mimics our original model that we trained on our data set. So it is basically used on complex data types. Like, SHAP values works on tabular data or CSV type data, but Lime actually works mostly on NLP or computer vision related data, where like text classification purposes, that could be image related models or video comprehension. In those cases, SHAP actually struggles a lot. So in those cases, Lime helps much better. And the Lime is basically highlighted in one of the medical imaging contest or something like that. I don't exactly remember. And from that day, Lime is being used for uh, uh, complex data. Primarily, it was being used on computer vision. Then later, it was being used in NLP. But Lime has some drawbacks. It is slower than SHAP. But SHTP is being used in most of the cases. It doesn't have any limitations. So this is especially for explainable AI. We have another techniques which is actually we can say counterfactuals or something like that. this actually gives you the actionable insights. So sometimes you can't quantify your model with metrics. So in that case, you do some sort of counterfactuals questions, like it actually shows what would need to change for a different outcome. So you have got some outcome, and if you were expecting some different outcomes, so in that case, what features could have been used for influence or something like that. So for these reasons, counterfactuals is being used, and so in most of the cases, we generate counterfactuals using different sort of optimization. There is no fixed rules for that, but we try to find the minimal change to flip the prediction. So you have to test that, and based on that, you will find out what actually will help you. And for this technique, we often use lambda function, um, and that basically runs this counterfactual generation related test, post prediction, and also it often caches this result to Amazon Elasticache or Amazon S3, something like that. So these are the techniques, but this explanation should be stable enough so that it actually have the ability to decide what to push for the production or not. So in my early life, I fell different type on different traps, like when my model were just uh, um, uh, giving different outputs in different retrain. Uh, so uh, so that was that in that time, my explanation for my production model was not same. So I think that has been changed now. So for our explanation stability, we used different metrics, and like for you could think of a scenario like you have your model where one model have let's say age is the most important factor, and you have another model, or you retrain the same model that could be after 1 month or after some time. In that case, you could see that uh, another feature like income could be the most important factor. So in that case, you your explanation is not stable. Your different retrain of models actually giving you different feature importance. So that's a very big issue. And to fix this issue, we track different explanation um, consistency across model versions. I'm not talking about model versioning tools, but you may have idea about Kubeflow or MLflow or something like that, whatever you want to use. So this is while you are working with explainable AI, you have to make sure that your explanation is stable enough. And in the production cases, you store these values in S3. As I already mentioned that Amazon SageMaker Clarify stores its explanations or SHAP files to S3. And besides, we also sometimes store these values in DynamoDB as well for Amazon related use cases. So this helps auditors to see real-time SHAP summary plots or counterfactual scenarios or explanation audit trail for these purposes. And in that case, CloudTrail works as well. So you need to make your explanation stable, and you should have persistent storage for your explanation for a long time. And also you should have production dashboard so that your different stakeholders have that read access to those dashboards, and based on that they take decisions. They don't have to wait for you. So in so far we have talked about the explainable models. but we have to take these models at a scale. We are going to talk about that. So when you are working with continuous monitoring, when you have your models in the production, you have to make sure you continuously monitor your model. And most of the time, automatic monitoring doesn't work well. So in that case, you should have human in the loop governance as well. So you can do both the things using AWS. So it's being said that deploying a fairness model is easy, but keeping it fair for a long time is not easy, because data changes, model changes, concept changes. Every changes that happens in the real world actually influence your bias, fairness, every single thing. So in back in 2021, I deployed a fraud detection model for our food delivery application, and in that time, bias metrics looked perfect while launching, and my manager was happy with that. But 6 months later, we could see some sort of disparate impact, that was dropped less than 0.75 or something like that. And but the model didn't change. Uh, so these things should be monitored. These things couldn't be monitored automatically. We could see the accuracy and other metrics the same, but there were a lot of changes. And for that, human review was needed because we got some feedback from our customer support that the model is not working as it was expected. So here, some sort of drift happens. One of the drift is bias drift. So in the bias drift, it happens in the data level, like data drift. So our production data stops matching our training data. So the data we are getting at the inference level is not matching the data that we used in our training level. And we could have the concept drift as well. That does mean that the relationship between our features and outcomes are changes. So previously, your outcomes depended on your uh, age and income, but now your age only matters. Your income doesn't matter. So in that case, concept drift happens, and also user-based changes. In that case, population shift or drift happens. So these are the different bias drifts that happens in the continuous monitoring. We and for that bias drift detection, we use different real-time metrics tracking. We use DynamoDB. We use Amazon Lambda or Amazon CloudWatch to fix these issues. When we do prediction, we actually uh, store those predictions in DynamoDB with different time stamp and plus demographic metadata. And in an hourly basis, Lambda function calculates different fairness metrics on those data, and that data is being sent to the CloudWatch so that it can trigger model retraining, or it can trigger the compliance team or something like that. So using these AWS services, we can do the bias drift detection. Also, we have different alert thresholds. We do maintain basically three-tier system. One is yellow alert, another is orange alert, and another is red alert. This actually depends on your company, how they maintain their wear room. So using these alerts, you actually get to understand how much importance should be put on this issue. And solution two could be the model governance. Model governance actually you have some sort of model cards where your model version is put, training data provenance is put, and fairness metrics, different known limitations can be put as well. So it is basically, you can think of like your model has been given some sort of attribute that actually helps people to understand how your model is, how good or bad or something like that. So it has some sort of template we usually follow. I'm not going over this right now. And we could use some sort of automated audit trails. As I already said, that every prediction we store them in we do the SHAP value calculation on them. We do the fairness metric calculation on them, and then using the timestamp data and without changing the data, we store them in either S3 or DynamoDB, so that in later we can just have their understanding, or compliance team would access those data to actually check any compliance has been violated or something like that. So these things are pretty common in strategy. And Amazon has another thing that I forgot to mention, which is human in the loop, or Amazon augmented AI. You see that your data triggers, your model triggers, like your model is showing low confidence than previous incidents, like your model is not giving the inference the same way as it was giving in the past. So in that case, you can just initiate the AWS Amazon augmented AI workflow. This will actually give the human reviewer the evaluation request, and there some sort of decision will be finalized, and then the inference will be given to the user. So this is another thing. And there are some cultural shift that I want to talk about. uh, Basically, in the past, we engineers owned the models, and different ethics team or different stakeholders basically reviewed our work quarterly. But these days, engineers and other stakeholders co-own the product from the start. And we actually started using uh, these best practices from the day one, so that we don't face any fallback in the future time or prediction or production system. So this is one thing. And if I talk about the complete pipeline, so model makes the prediction. That's the first step. And we start some sort of bias monitoring checks and fairness metrics checks in real time. If that violates or underrepresented the threshold, in that case, there's being sent some sort of human review using the A2I, which is Amazon Augmented AI, or human validates or corrects the prediction. Different feedbacks are being logged and metrics are being updated. These things are done. If bias drift detected, model retraining happens as well. So these things are pretty common. And we are going to talk about the uh, whole process that we follow. I'm going to shorten uh, this presentation. So we can have we can operationalize this responsible AI artifacts. So we actually follow these steps specifically. We have some sort of testing framework for bias, and most of the time, if our platform is AWS, in that case, we use the automated SageMaker clarify reports, which can be integrated in our CI/CD pipeline, deployment pipeline. And we also have some governance checklist, which is mandatory pre-release validation. what can be done after certain scenario is faced or something like that. We have some governance checklist, and we have, as I have already said, we have production dashboard, which actually often consisted of use if you're using AWS, then you have the AWS Clarify dashboard, where you can see the SHAP values, line insights, every single thing. Or you can use the Prometheus or Grafana for these purposes if you are just building your own ecosystem. And we also follow some sort of compliance guidebook that's being given by AWS or something like that while you are working with AWS. In that case, AWS follows some sort of SOP or standard operating procedure using their well architected from framework. So we work using these guidelines. And at the end, I would have a closing reflection, which is engineering. We are basically engineering for trust. So yeah, here our responsibility is not just technical, it's societal. So if you want to make AI safe, you have to change the society as well. You cannot engineer the technical aspects only. You have to engineer the society as well, so that society builds trust. As we can see these days that there's so much blaming that AI is going to have your job, something like that. But here we can see that whoever is using AI is actually accelerating their productivity or something like that. So you have to make responsible AI by mitigating the bias, by mitigating the fairness disparity, and also making your AI models explainable enough so that people understand how they got their predictions, and they can build trust. So that's all. If you have any question, please let me know. Um, I think I'm done.
Thank you so much, Wade. It was really a wonderful session. So, if you have any question, you can unmute yourself and ask questions, or you can write on the chat.
Okay, thank you, Mobasshir Bhai. I have two or three questions. At first, if I want to become a ML developer, what can I do? Who is AWS service? I need to know how I can start to develop the ML, because most of the people are novice. So how we can start the ML or AI? This is just a basic question. How we can start the MI or AI
So
project?
yeah, so for if you want to start with machine learning in AWS platform, in that case, you can start with Amazon SageMaker, because SageMaker is a studio. It's not a service where you can do all the things that related to your AI workload. Uh, they have foundation models. They have your data wrangling studio as well. They have your model training studio as well. They have your post training or deployment related or deployment or inference related uh, services as well. So that one studio holds all the services that's needed for ML related works.
Okay, thank you. I have another question. Which service the best suite for monitoring the AI bias for real-time production environment? মানে অ্যাকচুয়ালি কোন সার্ভিসটা আমরা এআই বায়াসের জন্য মনিটর করতে পারি? এডাব্লিউএস এর কোন সার্ভিসটা অ্যাকচুয়ালি মনিটরের জন্য বেস্ট ফর এআই বায়াসের জন্য?
AI bias জন্য as I already mentioned, we can use AWS SageMaker Clarify. Besides, we can use AWS CloudWatch, or we can combine CloudWatch plus AWS Lambda as well to monitor the ML bias.
Okay, I have another question. How we can protect the sensitive data of AI workflow? Actually, আমরা কিভাবে এআই ডাটা সেন্সিটিভ ডাটাগুলো আমরা কিভাবে প্রটেক্ট করতে পারি ওর ট্রেনিং ডাটাগুলো কিভাবে আমরা প্রটেক্ট করতে পারি? হ্যাঁ, হ্যাভ এনি সলিউশন? হ্যাভ এনি
Yeah.
বিল্ট ইন টুল? প্লিজ।
Definitely. So, as we are already accustomed to S3, we can do the federated learning where from the SageMaker, you can just access your data. You don't have to bring in your data to Amazon SageMaker. Your data will be stored in S3 and that will be encrypted at rest. And while they are in transit, at that time data will be encrypted as well. But using the AWS SageMaker pipe mode, you can just access your data as if your data is in your own computer or something like that. So that actually gives the security of your data.
Okay, thank you. I have last one question. How we can handle the model deep detection?
Model drift detection, right? So for model drift detection, AWS has several services. Uh, uh, So while you are using AWS, AWS keeps that matrix in the AWS Cloud Watch in most of the time. So using those and defining different metrics and thresholds in AWS Cloud Watch and AWS SageMaker, you can just get the model drift detection.
Okay, thank you. Thank you for your answer.
Thank you so much for the questions.
Okay, thank you.
Yeah. Are there any questions left? You can also write on the chat. Then I guess we can end the session. Also, are the session recorded? Okay, yeah.
Yeah, I think so. The session has been recorded by me.
Oh, yeah, sure. Then you can share me the recording. Also, we can share it with the members.
Okay, sure,
So
definitely.
thank you
I will
so
share
much,
you the
Bhaiya.
recording. Thank you so much,
Yeah,
Vera, for having me.
yes. We are glad to have you, Bhaiya.
Thank you.
So
Thank you.
thank you so much.
Thank you.
Okay, thank you. Bye-bye.